session before lunch, so hopefully everyone having positive, like enough energy to listen, spend 10 more minutes. And welcome to TIA. So we are the one of startup from TIA. So we have office at first floor. We help companies mostly building the secure CI/CD pipeline or end-to-end automation over all the clouds, like we can say cloud agnostic CI/CD platform. So here my talk regarding introduction to security conscious CI/CD pipeline. So when we are building our product, so almost everyone like in this track I see cross-site scripting or SQL injection. These are the popular. They come very late. Like once you are on the production, after that it comes. So somehow we compromise security as at a time of development. So my talk mostly focused on how we can incorporate security during our CI/CD, or how do we protect the CI/CD from these security issues. Sorry, guys. So coming to my introduction, I have already got a good introduction from our host, so nothing to say much. So I come up, I started my career as a developer, so before 15 years, and then started building a lot of agile applications, mostly came from the Ruby-on-Rails background, and then started building these solutions where these are like early stage people are doing all those TDD, test-driven development and all those things. So in CNCF also people are more focused on doing the testing, really the unit testing or integration testing. But security is another implementation which comes like as a DevSecOps. So people do later stage, not at the time of development. So we are also doing the similar thing, but then later on we realize that is also a critical part which we should include in our pipeline. So I think most of people are already knowing what is the CI/CD or what is the use of CI/CD. So I just like to put some words here. CI/CD in simple word I will say it's a series of basically automation processes where we try to automate our daily work, like as a software developer or as a DevOps engineer or as a QA engineer. We try to automate all those steps so that we can save our time, and also within the less time we are able to roll back the things. So those are the basic features of any CI/CD, and at the end it comes like all the manual works we should automate so that we can be more productive as a software team and able to deliver fast our software, which is like quality code in the fastest way. So why we need a secure CI/CD pipeline? So there are two types of security considered. I think Shyam, keynote speaker, he has already told some of the security issues in the pipeline basically, or the you can say supply chain of the software. Here, one is the build system, like secure any CI/CD solution, how we can protect that so that any attacker should not able to take the control, because CI/CD is the place where you keep almost everything, like you keep almost all your environmental areas, everything, and try to give access to the CI/CD as a user, IAM user, so that all the things it can do like a developer. So CI/CD security is important because of you have full access to the CI/CD of your infra as well as your source code as well as other artifacts. So next comes like our application level security. So mostly as a developer we are taught you should write a secure code, you should write a security practices, everything. But CI/CD is the place where DevOps teams are responsible to make the system secure. Like how the CI/CD is able to access your source code repository, or how the CI/CD system is able to deploy applications on your cloud. So almost every resource it has access. So here one example I want to look at GitLab. So there are a few attackers, and mostly attackers want to exploit your CI/CD pipeline to steal the system information so that they can get a control over your application. Another one is like these GitHub or GitHub actions are almost de facto things to development. Any developer who would start their life or any experience there who want to keep their source code, either they will keep in public or they will keep in private repositories. But by default, GitHub actually came some 2 years back. GitHub actually introduced the CI/CD pipeline, and almost every open source project has adopted it. Previously, mostly people are using Travis or different CI practices. But once GitHub action came as a default for the GitHub repositories, so all open source project has taken it. So if that is taken means, if I am a hacker, I can just write down my malicious code in your pipeline code, means GitHub action scripts, and then try to take control of the system if any maintainer is accepting my PR. After accepting my PR, I have full access to anybody's system who is using this open source repository. Not just almost 90% people are using open source Node.js plugins or open source packages. I can easily go there and I can write my malicious code and then take the control of that open source. I don't need to worry about. Only whoever the people are using that system, I can take control of that system using my application. So this kind of attack is called basically supply chain attack. So here I am not trying to directly attack your system. I am trying to attack those third-party vendors or third-party libraries or third-party services which you are using in your application. So here people are not that much conscious about security. As a product, you are very conscious. You as a developer who want to do, you are very conscious about security practices. But what about third-party vendors, third-party libraries, third-party applications which you are using in your application? So some common security risk if I say. So like if you put as a system, like CI/CD system or insufficient either pipeline-based access control. So you might have heard about RI. So here we are trying to give access to all the developers, all the team members. But I am talking about ERI. ERI pipeline-based access control here. You are giving access to the pipeline. Pipeline is also, you can imagine like always whenever we create a pipeline, we try to do an IAM access to the pipeline. So pipeline becomes like one of the actor in our software development team. So that actor, we have to take care of the proper security controls for that. Insufficient credentials sizing. So mostly people, like if team is more aware about security and all, they try to do some encrypted credentials or high quality credentials or longer credentials, not just hello at the rate. So these kind of credentials are really, really insecure. Or whatever the like I think on the internet you can easily get what are the best practices of credentials, how to create the credential, how to create username, how to create a password, those kind of things. And these are very important things for our operations people. Dependency chain use, so supply chain this is already covered here. Improper artifact integrity validation. So most of the time we are using Docker, Kubernetes and all the things we are trying to keep inside the artifact registry, Docker or somewhere. There are many open source also. So we have to take care of the security validations and everything for these things. Ungoverned uses of third-party services, insufficient logging and visibility. So right, last session also covered that main about logging and visibility. So that is also important stuff. So common how you can come out. So some issues I have put as a risk. There are some things which you can while implementing in CI/CD pipeline, like CI/CD as a code or CI/CD as a system, you can introduce cheap modeling and access control. So cheap modeling and access control are initial steps when you are planning software development. That time or when you are trying to architect software, you are thinking which system to use or what libraries to use. So if you can put these data in your deep modeling sheet where you can put, okay, this can come out of the library or these are the third-party risks available. And how do you overcome for that if you want to use that solution? Integrate source composition analysis, SCA. So SCA to avoid all these services like your supply chain attacks where you already trying to scan all those third-party libraries and everything. Integrate static of security testing, which is mostly on our initial page when developer is trying to write the code. That time you can integrate this SAST. Integrate dynamic application security testing, AST. So these things Second stage basically after once a developer using the code, that time you can integrate these tools to scan, integrate runtime application self-protection, where once the application is deployed on the cloud, that time you should put these tools so that they behave like a security guard for your application. Auditing, login, monitoring, observability, and alerting. This is very critical for any application, and everyone should have it. Like these days, very popular tools like Grafana and Properties. By default, comes for Kubernetes and contaminated within the default tools. Clear branch protection rules. So branch protection rules are also very important. Like everybody in the team should not have push requests, or like they should not able to push the code to all the branches. So feature-based implementation teams should use. So if a new developer are coming or any development people are coming, they should be assigned to one feature branch. That branch should have a proper review mechanism, like raise a PR and then try to merge it to your main branch so that other people can get that. So this is what SDLC lifecycle I try to list here. So here all the things I try to highlight it as per the stage of the software development, how we can utilize these security practices while developing the software. So number one, secure design and architecture. So we use secure design and architecture or when we do application or feature development. So most of the architects or the people who want to design the application, this is the first phase where you can start fleet modeling planning or access control, access security control. How do you put the access to different resources in your organization? Next comes like a pull and commit. So whenever our developers start developing the solution, they will start pulling or cloning or committing the source code. That time basically you can start static code analysis or static application security testing or SCA, software composition analysis. That is done by, there are many tools available, open source as well as paid solutions available in the market. You can use it. Just search for static SAST tools or SST suite, you get many options. Next comes like continuous. So security, secure code review is a continuous practice. So you should always do it. Next comes like a developer code. So when developer is starting coding, so integrate SAST or via ideal plugin. So mostly people use code editor or different. So there as a plugin you can implement. So while coding itself, you can get these suggestions. This code is not secure, or this library is not secure. These many vulnerabilities already present in this. All the alerts you start getting inside the developer machine only. You don't need to build these things inside the CI/CD. So next step comes like continuous building, integration and testing. So build and integration, that time also we can implement SAST and SCA. Then we do packaging. So packaging like building a Dockers or containers or images or the artifacts. So that packaging also we have to scan it. So next comes like a testing and staging testing. So there also we can implement this in IAST basically in practical application security testing, which is the mix of SAST and EST. Next comes when we publish our artifact repository, like all the Docker images, anything we publish in the repository, we should do the image scanning. By default, all the Amazon EC or GCR everyone provide this one, but you can also use your own scanning. Sometimes you can use self-hosted repository also. So this is the mandatory step for repository. And then you should assign those repositories. Next, scanning is one thing, signing is also one thing which protects your image from another individual who can directly use it or you can violate it. Artifact, another one, continuous, this is continuous process basically inside the pipeline. So artifact and image repository scanning. Next comes like initiate infrastructure. So when we try to build the infrastructure like some Terraform and all those things we use for building infrastructure, and that comes under the continuous deployment inside the pipeline. So systems, containers, network vulnerability, these things we should scan, and then we should send to our basically deployment system. Here after deployment also, that is continuous monitoring where people are trying to do all as I said, like penetration testing and all those things. That is part of here. And here runtime application self-protection also important. It becomes like the security guards. Whenever anybody in open network try to violate the traffic, that time you can take care of these things. So here few things are basically like as per the pipeline, I try to list these things so that we can utilize these. So once if you say how do we build the secure pipeline? So CNCF pipeline stages with the security steps. So number one, like development, version control, pre-build, post-build, QA, staging, production. These are the standard CI/CD steps, and everybody should follow that to make your applications secure or the source code secure as well as deployment secure. All of these I have already covered in the last minutes. Here also, same thing I have listed within the development, what are the things you can do, version control, what are the things you can do, pre-build, static applications, credits, SAS, post-build, dynamic analysis, at the time of QA, security testing of third-party components, scanning the security, we can do. So these things you can implement in your pipeline. So once we start implementing, so I just try to put into steps, same thing, like pre-commit objects, you should have a clear, you should clear clean modeling, clear ARA, and clear manual code use, email notification, configuration, because as a DevOps engineer or as Ops engineer, if you try to follow these practices, here I am trying to cover in 10 minutes, it is not 10 minutes, it will take minimum 1 month to implement such kind of practices for any application. Good application, 1 or 2, like if the application is smaller, 1 or 2 is enough, but your application has a good component, it takes a good amount of time of research and all. So next comes like commit time checks. So as a commit time checks, compile, build, and run SST, automate security testing, Gartner matrix. There is a Gartner matrix available. You can check against that. Break the hits. So in this system, you should try to break the hits so that attackers will not be able to break that. So build time checks, comprehensive SST, SCA, security testing, Gartner matrix, break and build. Time. Testing time checks, broader SST, PST, KST, malicious code detections, Gartner matrix, and then break the hits. Deployment time, so there are 2 types of pre-deployment checks, post-deployment checks. So configuration management to begin and end deployment, and post-deployment, security scanning, vulnerability scanning, post-bounding, and threat detections. These are the things you can do in a pipeline. So whatever the last discussion I covered, these are the developer level, means at the time of coding. But before that, it's a system level, like as a configuration, how if you want to set up a Jenkins as a pipeline, all those things that are about engineer, you have to take care. But if you are using third-party tool like RazorOps or any CI/CD solution, mostly they try to cover it. If not cover it, you can also build these things for yourself. Yeah, that's it from our side. We have a booth, so you can visit our booth for more information. Everything is there, you can always reach out. And you can scan the code if you want to set up a meeting. And I think there is a very, very delicious lunch is waiting down at 2:00. You can enjoy that. Any question or anything, if you want to ask, you can ask.